In this video, we're going to be talking about how to use threshold divisors with Webster's method. Just like we talked about how to use threshold divisors with Jefferson's method, this is going to be another topic that's optional that you don't have to use on exams or homework if you don't want to. But if you're somebody who hates guess and check and you want to learn this method because you think it'll be easier, you're welcome to use it. Threshold divisors for Webster's method are a little bit more complex because with this method, your initial allocation might be too low or too high. If the initial allocation is too low, this means too many natural state quotas have rounded down and we need more quotas to end in 0.5 or higher, so they'll round up and will allocate more seats. Here, divide each state population by the smallest number that will round to the number of seats you'd like them to get. This number is usually something 0.5. So we'll look at some examples of how we could find this. Suppose state A has population 532 and its natural quota is 8.0245. So it has been initially allocated 8 seats. What divisor will result in a quota that would allocate this state 9 seats? So we know that if their quota was 8.5 or higher, it would round up to 9. So a quota of 8.5 would be good enough. We want to find a divisor that's going to get us a quota of 8.5. So if we take 532, our population, divided by 8.5, which is the quota that would get us the number of seats we want, this tells us a divisor of 62.5882 would get us a quota of 8.5. And to check that over here, if we take 532 divided by 62.5882, or we could also go a little bit smaller than this if we wanted to, that would give us a quota of 8.5000, which would round up to 9 and cause this state to be allocated 9 seats. Now let's look at another example. Suppose state A has a population of 532 and its natural quota is 7.8856. So it has initially been allocated 8 seats. What divisor will result in a quota that would allocate this state 9 seats? So here, this number rounded up. In our first example, we looked at a quota that normally rounded down. Here we're looking at a quota that would round up. So again, we would need the quota to end up coming out to 8.5. It's going to be the same divisor that would work for this, but this divisor is probably going to differ significantly from whatever our natural divisor is. So again, it would be 532 divided by 8.5, because 7.8 already rounded up, would give us the same thing. And again, we can see over here, if we divide this population by this divisor, we would end up with a quota of 8.5, which rounds up to 9. So now we'll look at an example. This is a problem that we saw in the last Webster's method video, but now we'll take a look at what the threshold divisors look like. So the modified quotas that we found that worked out, we did when our divisor was equal to 65, so let's see where that came from. The threshold divisors for each state in this case, we would divide by the number that's going to round to the number of seats we want them to get. So let's see, Windfall initially got 30 seats. We would like for them to get 31 seats, so if their quota had been 30.5, it would round up. So that's why when we find their threshold divisor, we divide their state population by 30.5, and we get this threshold divisor, 65.5738. For Dragon Roost, they initially got 2 seats. Their natural quota was 2.2. But if this quota had come out to be 2.5, it would round up to 3. So that's why we divide their state population by 2.5. This tells us if we use 58 as our divisor, their quota would come out to 2.5 and they would get 3 seats initially. For Kakariko, we take their population, 160, divide by 2.5. Originally, their quota was 2.4, which rounded down. If their quota came out to be 2.5, it would round up to 3, and they would be due 3 seats. And we got 64 as their threshold divisor. So we only needed to allocate 1 more seat if we go back to our initial allocation. We had 35 seats. Initially, we gave out 34. So we would want to use the first closest threshold divisor to the natural divisor. And the first closest threshold divisor we have here is the one for Windfall. So if we used 65.5738 exactly, that would work. We could also make it a little bit smaller. As long as we don't make it smaller than 64, that should still be a good guess. which is why 65 ended up working here, and if you tried to do this with 64, you would end up giving out too many seats. So this is how we get our final allocation of 30.7 rounds up to 31, 2.2 and 2.4 both round down to 2, giving us 35, which works out. Now we're going to talk about how to find the threshold divisors for Webster's method in the case where the initial allocation is too large. And this one's a little bit more confusing. If the initial allocation is too large, this means too many natural state quotas have rounded up and that we need our modified divisor to make it so that more of the modified quotas end in decimals lower than 0.5. Here, divide each state population by whatever number of seats you want the state to get 0.5. When choosing a modified divisor, if you make it slightly larger than the threshold divisor, it should work. Note, generally, if the initial allocation is too large, you don't need to bother with threshold divisors of states with natural quotas that already round down. So we'll look at some examples here. Suppose state A has a population of 532 and its natural quota is 8.5434, so it has been initially allocated 9 seats. What divisor will result in a quota that would allocate this state 8 seats? So if their quota is something like 8.4999, this is enough to get it to round down. So what we can do is take our state population, divide it by 8.5, and this will tell us exactly what divisor would guarantee a quota of 8.5. And it's still 62.5882. But what we could do is we could take this and make it just a little bit bigger. So we want to make this a little bigger. If we make it a little bit bigger, say, 62.6, it's just a tiny bit bigger than this, this should work. So we can take 532, divide it by 62.6, and this gives us a quota of 8.4984, which will round down to 8. Now let's look at another example that shows us why, if a quota already rounds down, usually you don't need to bother with finding the threshold divisor in this case. So now let's say, suppose the state A has population 532 and its natural quota is 8.0345. So it has been initially allocated 8 seats. What divisor will result in a quota that would allocate this state 7 seats? Meaning we gave out too many seats initially, we want it to go down. So for a quota to give this state 7 seats, we would need anything between 6.5 and 7.4999. So any quota between here would work. It's going to be a lot easier to force a quota to come out to be something like 7.4999 than 6.5, so we'll look for something around here. So we would take our state population, 532, divide it by 7.5. This comes out to 70.9333. So this tells us if we use this divisor exactly, we're going to get a quota of 7.5. So we want to make this one just a little bit bigger. And we can try 71 because it rounds up to that. So if we take our state population, again, 532, and divide it by 71, we end up getting a quota of 7.4929, which rounds down to 7. So now let's take a look at this example that we saw in the last video on Webster's method, but now we're going to see what the threshold divisors look like. So our initial allocation here was too large. We ended up giving out 101 seats when we only had 100 seats to give out. The modified divisor we had that worked was 70. So let's take a look at what the threshold divisors are. Traverse Town had a natural quota of 28.6, which rounds up to 29. We would want them to round down to 28 instead because we gave out too many seats. So if we take their population, we divide it by 28.5, that tells us if we use a divisor of 70.1754 exactly, they would get a quota of 28.5 exactly. So if we wanted to use this as our threshold divisor, we would need to make it a little bit bigger. So maybe something like, 70.2 if we wanted to try this one out. Now for Destiny Islands, they initially rounded up 2. Their natural quota was 20.7, which goes up to 21. So we would take their population, divide it by 20.5. They end up getting a threshold divisor of 70.73. So that tells us if we use this divisor exactly, they're going to get a quota of 20.5 exactly, but we'd want it to be a little bit smaller than that, so we would need to make this divisor slightly bigger if we wanted to use it. So maybe 70.8. Now if we look at Radiant Garden, their quota already rounds down. We already have 22.06. So in this case, we're going to skip finding the threshold divisor for this one because it would be a lot more work to get them to have a quota of 21.4 something to cause them to round down to 21. So we're not even going to bother to find this one. Usually you don't need to. I'm definitely not going to give you an exam where you need to do that. Now we'll look at the next one, Castle Oblivion. They also rounded up initially, 28.5, which rounds up to 29. So we took their population, divided by 28.5, and we get a divisor of 69.8246. So if we wanted to use it, we could try making it just a little bit bigger. Maybe we could try 69.9. The modified divisor we found that worked was 70. And the reason that this one should work is because 70 is a little bit bigger than this, which is our first closest threshold divisor to the natural divisor. Our natural divisor was 69.8. Notice that this threshold divisor is only a little bit bigger than this. We want to make it a little bit bigger. 69.9 would work. 70 also works. As soon as we get as big as 70.2, it won't work anymore. So if we use 70, if we use 70.1 might also work. 69.9 should work. They'll all end up giving us a final allocation that adds up to 100, which is the right house size.